Hey everybody, this is Larry. This is week 2 of the Leetcode Daddy weekly premium challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem, Squirrel Simulation. A problem I haven't done before. I'm still in Hiroshima today. If you watch my daily video, you'll see the intros. I took a nap and I just woke up, so I think like it's not really. I don't know. I didn't really go over his background, but I would say I started a new vlog channel of my journey in Japan. If you want to check that out, let me know, and I'll put in the comments below. Yeah, it's very new. It's a little bit rough around the edges, but I'm still playing around with it. Anyway, today's problem is 573 squirrel simulation. That's it. Given two integers, height and width. You're given trees. You go to trees. Trees, dude. Nuts at these places. Squirrel should go to nuts first. Okay, so this could be a tricky problem. So basically, you have to collect all the nuts, but you can only hold one nut at a time. So you go to so this squirrel goes to a nut, go to the tree, and then goes to another nut, and goes to the tree, and so forth. The first thing that I look at is kind of look at how many nuts there are, and nuts is 5,000, huh? Because to be honest, initially I thought possibly it could be one of those NP problems, meaning like like a variation of traveling salesperson and stuff. So when you look at constraints, sometimes it's a little bit of a giveaway, because you're like But I think this one is maybe more straightforward. I think they are just like it's a case analysis, because basically, okay, you have the starting point, which is the squirrel, but other than that, you literally you're at the tree after every nut. So then after every nut, you're going from the tree, get another nut. It doesn't even matter at that point which nut, because you have to go to every nut one at a time. So that means that the only differentiating point here for this problem is which is the first nut that you go, and then go to the tree afterwards. So I think we can calculate that basically. Yeah, we can just calculate that brute force for all of them, and of course you have to be careful, because if you're not careful, you could do it in n squared, which for 5,000 is getting a little bit sketch, at least in Python on Leetcode. But yeah, so okay, so let's start coding. I think that's generally the idea. You could do it in linear time, I believe, unless my idea is wrong. But basically, the total is just going to be, like I said, from the tree to every nut, right? So that's not the best total, but that's the total of all the distance between the nuts, and we can calculate. I'll show in a sec, but we can calculate the total for starting at each nut by subtracting this from it, or that from this number, right? So for x, y in nuts, maybe nx, ny for nuts, x and nuts, y. And I like to maybe just tx, ty for tree x, tree y is equal to tree, right? So we add nx minus tx plus right? So that's the total distance, right? And then now we can brute force each nut in that. Okay, so there may be multiple ways, so I don't have to kind of see, but let's just say best is you go to I don't know, just infinity, right? I'm not gonna assume anything. That makes it easier to not assume anything. But then now, so here, go to nut, then tree, right? Yeah. Is there any other way? I guess you could go to the tree first, but that always will, because this is Manhattan distance. It doesn't ever make it any sense. So okay, so go to nut then tree, right? So let's also say sx is equal to squirrel. So sx s maybe I should win like a distant formula, but yeah, right? Nut to tree to nut. right? So this is the distance, and then plus from the nut to the tree. Actually, I guess in this case, oh, this is wrong, or this is insufficient, right? Because from the nut to the tree, and then you have to go back. So this is 2 times this. That's why I was like, something feels a little off, right? So this is the total because now it's the distance starting from the tree to every place, right? So then now this is going for a nut, then tree. So nx minus tx. Why do I have a minus here? Right. So this is that, and then now d plus total is going to be the entire thing, except for you double counted. So then now it is actually minus this because now we triple counted it, I guess. So actually we can just I think just remove this and then do this, and that would be fine. Maybe I'm off by 1 or something. I don't know. I'm always off by something. And then yeah, and then now we could minimize this and that, right? Let's give it a spin. It should be O of n, so it shouldn't be timing out. Let's give it a spin. Let's give it a submit. All right, yeah. This is linear time, constant space. I'm going to draw real quick, but basically, because I wanted to make sure a little bit that I get it right first, to be honest. But basically, the idea is that okay, so now you have a sort of a Manhattan distance minimum spanning tree, right? So you know you have this node, and then you know it goes to some other nodes. I need a drawing thing. I'm drawing with the touchpad, and this is like annoying, right? But the idea here is, you know, and that one is terrible actually. So you could just reduce this to this, right? This is the Manhattan distance, and you know, pretend there are more because it's very hard to draw, as you can see for me here, because I don't even have my mouse. The idea is that let's say you're a squirrel. Change the color. Let's say you're a squirrel. Basically, the idea is that now you're going to you're testing brute force going to a node, and because you already did the math for this path times 2, because you know that's the way that we did it. Now we can just kind of, you know, do the math with respect to subtracting out what we haven't done and stuff like that. And because we've done that, then we can do it for every I'm trying to remove this real quick. Oops, not that one. Yeah, you could do that for everyone, every nut, and this is going to be just linear time, as you can see. Yeah, that's all I have for this one. It's a cute problem. I dig it. It's a good thinking problem. So yeah, let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. I'll see y'all later and take care. Bye bye.